Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about what is shear wall. What is a shear wall? Shear wall is the vertical structural components generally made up of reinforced concrete with the purpose of resisting and transferring both lateral and gravity. Vertical loads. Thus these walls are generally designed in order to make building resist against the seismic action, wind loads, and even sometimes for the uneven settlement as the prone and distinctive lateral load is seen due to these conditions. The basic purpose of the shear wall is to prevent the shearing action of structure, especially vertical member-like columns, so that the safety and serviceability of the whole structure increases. Shear wall is installed on the basis of either cantilever action or truss action on basis of the assumption of their structural performance as the load acted upon them. In any structure or system, when the load or forces are applied, the forces always try to travel through the weakest path by causing the cracks or failure in the structure. And as we know, the easiest path for shear failure in structure is the diagonal plane, in case both lateral and vertical load are being applied, actually its principal plane. The shear wall thus produces the larger diagonal plane containing area to easily accommodate the shear forces by resisting and allowing to create cracks within them. This mechanism thus inhibits the truss behavior of the transfer of loads in the shear wall. Due to these shear walls, the structurally essential components like column and footing do not get affected on large scale, which prevents the immediate collapsing. No buildings are earthquake-proof or fully earthquake-resistant. These shear wall kind of acts as fuse during earthquake, preventing only minor serviceable damages, increasing safety as the primary structural members like column are not severely affected, and the shear wall can again be reconstructed or renovated without demolition of the whole structure. However, in the cantilever action, they encounter the shear forces and lateral forces in form of flexural strength of the shear wall. Initially, every shear wall tries to go through this mechanism before the cracks are formed. The ductile property and resisting shear forces and bending via the flexural strength of such shear wall can be increased by inducing proper reinforcement design and detail considering the different parameters. Thus they are very excellent means for providing earthquake resistance to multi-stored buildings and high-rise structure. Why shear wall is provided? Shear wall increases the stiffness and rigidity, which helps in preventing excessive sway of the buildings or structures due to lateral loads, especially wind loads. It transfers both vertical and lateral loads safely to the foundation or ground. It increases the serviceability parameter of the building. The shear wall acts as a kind of fuse, or weak member, to dissipate the shear forces in the forms of cracks, and thus prevents the column from failing immediately. They help in decreasing the numbers of columns in structure as they have the ability to withstand the vertical loads. They promote less non-structural damages, which can be renovated. To support the multi-store high-rise building system. Types of shear wall. Shear walls can be classified into different types on basis of different parameters. They are: on the basis of the material used for construction. Reinforced concrete shear wall. The concrete shear wall is the most effective wall used in order to increase the stiffness and decrease the lateral movement due to shear and lateral forces. They are designed along with the specification. The horizontal and vertical reinforcement are spaced evenly over the plane where the shear wall is needed to be located. The basic design provision of reinforced cement concrete shear wall is available in IS 456-1978. 2002, however, they do not give the proper specification of detailing for the ductile construction of shear walls. However, they can be designed with various designing methods and analyzed with help of software for such purposes. Steel sheet shear wall. They are monolithically constructed along with the steel sheet wall, column, and horizontal beams, and thus acts as a vertical plate girder. Their property is very different from the reinforced shear wall. They do not break, thus entire shear resistance is governed by ductile behavior and flexural strength. These walls can act as plate girders along with the analogy of columns as flanges, the wall sheet, plate, as the web, and the beam as stiffeners. Wooden shear wall. They are the wall built with the help of wooden boards or ply and also timber planks. They contain the vertical and horizontal struts for compression and tension forces attached at the back of the ply or planks. Sometimes even bracings, diagonal supports, are provided to increase the stiffness and decrease the shear action. Hollow concrete blocks. They are economical methods to construct the shear wall and used instead of the RCC shear wall. The horizontal and vertical reinforcement is placed in such shear walls too, but their structural performance is comparatively less than the reinforced shear wall. On basis of location and construction, shape. Column-supported periphery shear walls. The shear walls are provided near the column situated at corners. They are very useful to increase the torsional resistance. They also especially used for architectural purposes. Core-type shear wall. These are the shear wall constructed inside the building located centrally as much as possible. The hollow case of the rectangular core is created by constructing a wall in form of the channel of the central or symmetrical part of the building. Such shear walls are constructed suitably as encasing of the lifts, elevators, or staircase. Rigid frame shear wall. These shear walls are intruded between the rigid frames. They can construct be monolithically or separately attached with anchorages and ties to columns. Simple rectangular and flanged cantilever shear wall. These walls are called a cantilever, as they are only erected over the ground with a foundation isolating them from other vertical members so that they act as cantilever beams. They can be subjected to bending and shear and consist of boundary elements. They can be a simple rectangular shaped slab or flanged with different shapes like T, L, etc. placed at various locations. Couple shear wall. Shear walls with the perforated opening can be simply called as couple shear wall. Also, it can be understood as the two adjacent shear walls connected with the strip of the thin beam, also called spandrel beam. Coupling beams dissipate the energy along with preventing the major damage in the shear wall. On basis of behavior: squat structure wall, slender wall, ordinary manner wall, ductile manner wall, dual system wall. Where it is provided location of shear wall. Shear wall location might vary from an architectural and functional point of view. However, it may be possible to find the ideal location of the shear wall by analysis of various parameters such as story displacement, base shear, story drift, etc. under lateral loads. Shear wall is best to locate in the middle of the structure or building, causing symmetricity. The shear wall at such location helps to decrease the shear force symmetrically and equally in all parts. Location of shear wall. Thus it is best to locate the shear wall along with lifts or the stairs, as the lifts or stairs are located in the middle of the structure as much as possible for better accessibility. Moreover, there will not be any opening needed for the wall at stairs or elevators, so shear wall with no openings can be constructed for better performance. But it is not always possible or economical to construct the shear wall a middle, so the wall can be also formed at the corners or external faces of the buildings. However, their efficiency is not much as maximum as placed at the asymmetrical points. Shear walls can be located along the shorter dimensional plane of the structure where the relative distance between the column is relatively greater and it is uneconomical to provide column between them. The larger dimension of the structure consists of numbers of the column placed relatively nearby each other compared to shorter, so they might not need it. Whatever the location can be, it must be kept in order to maintain symmetry to prevent ill effects and twist in structure. Application of shear wall. Shear walls are highly applicable to the building construction over the seismic zone and place where there high wind flow with hazards of the lateral forces. Some shear walls can be used for aesthetic and architectural purposes as well. They are necessary to be constructed for high-rise and multi-stored building more than 10 stories. The shear wall can also act as the column for bearing the vertical load and also acts as a cantilever beam supported to ground. They can be used for the construction of an elevator or stairs casing as well. Disadvantages of shear wall. They stiffen the structure and make them rigid, so there is no flexibility and free swaying moments. Thus the energy created during seismic action is only encountered by internal work done or elasticity energy of the body. The shear wall converts the frame structure to behave like a truss structure. They are costlier as more reinforcement and concrete are needed. Their location can be hard to determine, and can cause unnecessary twisting and ill effect if not symmetrically constructed. Their energy dissipating capacity is low, and the whole energy or forces are withstand by themselves, leading to rapid cracking. Their thickness cannot be less than 100 mm. Different shape of shear wall reinforced concrete hollow core round elevators. Rectangular shape. L-shaped. C-shaped. Dimension specification of RC shear wall. The simple provision for design of shear wall as illustrated in IS 456:1978. The sum of major specification or thumb rules are: the thickness of the wall shouldn't be less than 100 mm according to Indian Standard 456/1978. However, in the improvised version, it is preferred to take minimum thickness as 150 mm and maximum as 400 mm. If permissible shear stress exceeds 0.25 *VFCK or wall thickness exceeds 200 mm, then reinforcement is needed to be provided in 2 layers or planes of the wall. The diameter of the reinforcement bar should not exceed 1/10 of the thickness of any part. The larger the width, the larger will be resistance against the lateral loads. Minimum reinforcement should be 0.0025 times of the gross area of the wall, provided in each direction, longitudinal and transverse, uniformly spaced. These will help to control the width of cracks formation. The maximum spacing of the reinforcement bar should not exceed 450 mm or 1/5 of wall horizontal length, or 3 times wall thickness, whichever is less. Wall with the boundary elements is less susceptible to lateral buckling, as their flexural strength and shear strength are high. So they are provided with a relatively thicker wall at edges. Lateral ties are needed to be provided around lap spliced bars that are larger than 16 mm in diameter. The diameter of the tie bar shouldn't be less than 5 mm or 1/4 th of the spliced bar. And the spacing of the tie should not exceed 150 mm in the center. Difference between column and shear wall. Sister no. Column. Shear wall 1. The ratio of breadth to the width of the column will be less than 0.4. The ratio of breadth to the width of the column will be greater than 0.4. 2. Concrete columns' minimum width should be 200 mm, however many codes prefer it be of 300 mm for seismic resistant. The minimum width of the shear wall should be 150 mm. 3. Concrete columns realis resistanto earthquakes. Concrete shear walls are less resistant to earthquakes. 4. Normally concrete columns are provided at the ends of the room as per structural plan. Shear walls run along the full length of the wall. 5. Concrete columns cross-section can be square, rectangle, circular shape, L-shape, etc. The shear wall cross-section is like a vertically oriented wide beam. Sister no. Column. Shear wall. 6. The lateral load of the column is resisted by flexural deformations. The lateral load of the shear wall is resisted by shear deformation. 7. Minimum steel in the R.C.C column as per different codes is according to Indian Standard 0.80%, American Standard 1%, British Standard 0.4%. Minimum steel and R.C.C shear wall as per different codes are according to Indian Standard 0.25%, American Standard 0.25%, British Standard 0.4%. 8. A clear surface and column are not possible as column offset is seen at corners. A clear surface without any offset is possible in the shear wall. 9. A beam column system is more efficient and preferred for a low-rise structure. The shear wall system is more efficient for high-rise structures. 10. The provision of openings for door, window and column system is easy. The provision of openings in the shear wall system is tedious and needs special design skills. 11. Less carpet area is available in the column. More carpet area is available in the shear wall system as compared to the column beam system. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.